Alright, we are now online. Ready to go, 7:45. Just a little later than I hoped. Not gonna lie, I'm not feeling all too great, but I'll be fine, just a little under the weather. Don't know if you guys may or may not be able to tell by my voice. I did a couple of problems in class, but I'll go over any other ones that I need to, which again, I don't mind at all. But what I want to do is give everyone a chance to kind of ask questions, especially since, you know, we're not giving the formulas. You got to have them memorized and make sure that you know what you're doing with each of them. Your quizzes were handed back already, so you should be using those to help you study. And we'll go from there. Kind of get the chat box as a pop out. There we go. Got the video up. Ethan's online. I gotta move this. Oh, you don't have your math stuff with you. What'd you do, Ethan? He probably left it in his other binder at home. Or he left it at Elijah's house, maybe. I don't know. Alright. Oh, you're at your cousin's for dinner. Okay. No worries, man. Just, I mean, you should probably be with your cousins instead. But, you know, make sure that when you have the chance, watch over the video, see any questions you may... Wow, I can't talk today. Go over any of the problems that you may have trouble with, and, of course, bug me. Alright, so I kind of already did number 6, 1 through 6, in class with most everyone. So I'll jump back to those at the end. But let's start with number 7. We'll go onward, since there's kind of a decent amount here, right? 20 different problems. You're welcome, Ethan. I got you. So finding the area of our triangle, right? Our area of our triangle is 1/2 base times height, or you'll say base times height divided by 2. I got you, Jake. If I have time. Again, I'm not feeling as well as I would like, so if I have the energy by the end, we'll go through the whole thing. So again, don't count the dotted lines as part of your base. Okay, your base is only going to be the solid line. And then your right angle is going to show you where your height can be found. So we have 1/2 of 6 times 3. So I know that 6 times 3 is 18. 18 divided by 2, that's going to be 9. And then feet squared. Thanks, Jake, I appreciate it. Alright, not too bad. Oh my gosh. You guys are funny. Alright, find the area of our isosceles triangle. Yeah, plenty of tea for Mr. T. I think we discovered that's where I get my superpowers, apparently. Just need to make a cup of hot tea. Oh, he retracted his messages. That's funny. Alright. So in our isosceles triangle, we need our height, which we do not have. However, we have this really awesome theorem that tells us that we can solve for the height. I don't take vitamins, actually. I probably should. I used to when I was younger. You're welcome, little Link. Alright, so our Pythagorean theorem here for the height, we're going to say h squared plus 9 squared equals 10 squared. So simple calculations, just h squared plus 81 equals 100. I'm going to take away the 81. And what you're going to notice here is you're going to have h squared equal to 19. And when you take the square root of both sides, you'll see, wait a second, it doesn't reduce. Don't plug this in your calculator, okay? Because we're going to want our answers in our exact form. Bye, Lunatone. So h is going to just be the square root. Why is my pen not working? There we go. Square root of 19. Oh my gosh. I don't shop at Whole Foods often, but I'll think about it. No promises. Alright. So my height is 19. Don't get lost in all this work here. Right? Remember, your base is the total length of the bottom. Don't just all of a sudden go for the 9. Go for the total base. There's our 18. So again, our area is 1/2. And actually, for the rest of the people who like the other formula, right, we could say base times height. Oh my goodness, why can't I even? There we go. So our base is 18. The height is the square root of 19. So then, what we're going to do is we're going to say, hey, 18 and 2 can reduce on the outside. So my area is going to equal 9 rad 19. And then, of course, do not forget your units. Inches squared. I think I'm going to have to change the pen that I use. Give me a second. Alright. So now, on to the next one. Find the area of a trapezoid. So I'm going to first start by writing down the formula. 1/2 base 1 plus base 2 times the height. So if we look at our drawing, I don't have base 1. I'm missing this. And I definitely don't have the height. But from hopefully all the time you've seen these trapezoids, you've thought, oh wait, we know how to find the height, because we can split this trapezoid into 2 shapes that we do know how to work with. Right, on this left side here we have our special right triangle, our 30, 60, 90, the Mr. T triangle like I told y'all. So 30 degrees here points to the short leg. So that means we're going to take this 12 and divide it by 2. If you don't remember how to get that, just set up your formula. Right, so then 12 equals 2. I'm going to call that x. So then x is going to have to equal 6. Now, this part is 6, but the total was 17. So we're going to do 17 minus 6, and that's going to give us the length of the remaining part here, which should be 11. So therefore, if that part is 11, that corresponds with the top, so now we know our base 1 is also 11. Okay, got 11, this, still got to find the height. Our height is across from the 60, so that's our long leg. So we're going to say the long leg equals the short leg times rad 3. Alright, so then h equals 6 rad 3. Now I just go for it. Alrighty, 6 rad 3, and I got a 6. So my base 1 is 11. Base 2, remember again, is the total length of the bottom, which is your 17. Then our height we said was 6 rad 3. So order of operations, you need to add the numbers in the parentheses first. So 1/2 of 28. I think it's just me, guys. And then 6 rad 3. Alright. So 28 times 6 rad 3. I know half of 28 is 14. I'm going to do some mental math right now. 14 to 84. Rad 3. And then, of course, don't forget your units. Feet. So feet squared. Number 10, find the area of a kite. So again, looking at your formula first, and then Oh, okay. I know what's going on with the iPad. I know what's going on. I'm going to need to clean the screen for a split second, because I think what's happened is that some of you kids have been using my iPad, so you leave your grimy hands all over it. Okay, that should work a little better now. Alright, so for our kite here, we're going to have diagonal 1 times diagonal 2 divided by 2. So if we look here, diagonal 1 we can claim as this. The other one we can claim as diagonal 2. It really doesn't matter which one you claim. You just want to make sure that you're finding the lengths of each one. So the only thing we have is this 6 that corresponds with here. So again, that we do have a special right triangle here. So I do want to find the length of this side here. So that appears to be a 30, 60, 90 triangle. So therefore we know that the long leg we're just going to find by taking the short leg times rad 3 and then go from there. So we're going to have that equals 6 rad 3. So that's the fun one, 6 rad 3. That side is also equal to the right side, so we're going to say this is also 6 rad 3. Now to find that remaining part of our diagonal right here, we just have to remember that this is another special right triangle. That's our 45, 45, 90. So the legs need to be congruent. That means this right here is also 6 rad 3. So here's the fun part, right? Diagonal 1, super simple. It's 6 rad 3 plus 6 rad 3, which is the total of those two. That's going to give you 12 rad 3. You do not add the numbers inside the radical. Think of them as a unit. 6 pencils plus 6 pencils, you have 12 pencils. Right? You don't change the word pencils to something else. The other one, however, is a little different because it has a radical with a non-radical. So when you're adding those two numbers, you don't add the 6's and then keep the radical. That's not how it works. It's again a thing of units. You think of it as 6 pencils plus $6, right? I can't actually combine the units. So this diagonal 2 is actually going to just be 6 plus 6 rad 3. That is the actual length. That is the exact answer. So now we're just going to go straight into the math and substitute those into our equation. So in parentheses, diagonal 1 is going to be 12 rad 3. On the next part, we're going to have 6 plus 6 rad 3. Okay. Now, the fun part, cleaning this up. I know it's everyone's favorite. You could do this a couple ways. There are actually 3 distinct ways I can think of right now. You can distribute this into both terms, simplify them, then divide by 2. Or you can take that 2, you can simplify either grouping. You can take, let's say I say, oh, I want to do 2 divided by 12. Great, reduce that, you'll have 6 rad 3, then you distribute. Or if you see, hey, these two 6's can reduce with this too. Again, same thing, you would reduce them first, then distribute and multiply the parentheses. Really at this point, it's now what you're comfortable with. I always like reducing first, and I'm actually going to reduce this 12 with this 2. So this is going to get me 6 rad 3 times 6 plus 6 rad 3. So now the fun part, multiplying, distributing it. Boom, boom. So 6 rad 3 times 6, I'm going to have 36 rad 3. That 6 does not multiply inside the radical. The only way we can multiply in the radical is if we add another radical, which coincidentally is the second part of our distribution. So I'm going to have 6 times 6, which is 36. And if you're still kind of iffy on like what happens when you do a square root times a square root, that's okay. Just remember you're multiplying the numbers inside. So you would say, hey, I have the square root of 9. Well, wait a second, what is a square root of 9? You're going to get just a 3. So 30, what? Oh my gosh. 36 times 3. So now you're going to go ahead and multiply those two numbers. So then you should have 36 rad 3 plus, let's see here, 36, 12, 3, 12, 9, 108. So that's going to be 108. And I believe the units are meters. Yep, meters squared. Okay, I'm gonna check up on something real quick here. Okay. It says right now on YouTube that only 2 people are watching, which technically means only 1 person's watching. So hopefully you guys are actually using this video and not just waiting around. Right? We want to be proactive, not inactive. Okay. The area of a regular hexagon, side length of 12. So side length, we're going to go, oh, thank you, Ariana. So we got our 12 that's right here, that's the length of the side. And again, I kind of showed you guys in class, like, hey, why do we do what we do? What's our first step? How do we go about it? Right, so then here I see, oh, each of those corner angles in the center have to add up to 360. So 360 divided by 6 gives us 60. So we got a 60 here, there, etc. Now, our polygon needs the apothem, right? So then the apothem splits that angle in half. So now we do 60 divided by 2. That gets us 30. So what we're going to look at is we're going to look at this triangle here. It doesn't matter if you look at the left one or right one. So there's my apothem. Here's my 30 degrees, which we also can label the bottom as 6, right? Because these two have to be equal. All right, so now special right triangle. My apothem is across from the 60 degrees. So that means that's my long leg. So therefore the apothem is equal to 6 rad 3. All right, so now we got the apothem. We need the perimeter. So the perimeter is equal to the number of sides times the length of each side, 72. Now let's do our math. Let's do our formula. Area equals 1/2 the apothem times the perimeter. So 1/2 of 6 rad 3 times 72. So let's see here. I know half of 72 is 36. 36 times 6. 216. And of course, Ariana, you're watching, so you can confirm and check this. Okay. 216, and don't forget your rad 3. And that's going to be centimeters squared, because that is our unit. Ugh, I'm getting tired. Alright, so hopefully you guys are doing good so far. If there's multiple people, because I believe it's 3 now. Nope, dropped down to 2. Oh well. let's move on. Next one, number 12, find the area of a regular pentagon with a radius of 6. So radius, that's our length here. So again, same thing, you can draw your triangles. 360 divided by 5, that's 72. And then what'll happen again is when you draw your apothem, that's going to be 72 divided by 2, so 36 degrees. Now 36 is not one of our special right angles, so what we're going to need to do is we're going to need to do some trig on this. Trig, 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 trig. Again, looking at one part of my triangle, got my 36 right angle. My apothem is here, and I'm going to need part of my base. My radius was given to us, so that goes here. So for my apothem, which is going to be part 1 of our calculation, the apothem, so we see that that's the adjacent with the hypotenuse, so that's going to be cosine. Cosine of 36, my pen, equals a over 6. Again, keep your exact answer all the way till the end for as long as possible. If you have the funky calculators, and you want to type this in, that's fine. Just make sure you get 4 decimal places. My calculator is not here with me, so unfortunately I won't be able to do anything, and I don't want to do it on my phone right now. So there's our apothem. Now we need to go to the bottom, so the base. So for our base, remember that it's again a similar thing. This is our opposite over the hypotenuse. I should probably have labeled these. Adjacent, opposite, hypotenuse. So then from here, now we say our base trig function, that's going to be sine of 36 equals b over 6. Again, multiply both sides by 6, and now you'll have b equals 6 sine of 36. Alright, so again, one of the key things here is remember that that base, which is the bottom, is only this length here. Actually, that's not a good one. Let's do this. That length here is only this length here. So if this is 6 sine of 36, then when we double it, we'll get the total side length. So that's going to be 12 sine of 36. Now we can find the perimeter by saying, hey, there are 5 sides, and each side is 12, oh my goodness, sine of 36. So then just multiply the 5 and 12, so that perimeter is 60 sine of 36. Alright, now let's go in with our apothem and our perimeter and write out our expression. So the apothem is 6 cosine of 36, and then the perimeter is 60. My handwriting is not doing so good today. Now again, I'm not typing that into the calculator, but that would be what you would type in, and you should get your exact answer. Alright. Like I said, this is probably going to be about as difficult as it gets. As long as you remember your trig, as long as you keep your answers to the end, you'll be fine. Okay? Cool. Find the area of a square with the radius of 7. Now, I showed you guys a little cheat code that you could do for this one, but I'm not going to do it for this problem quite yet, because if you're paying attention in class, you could have this done super easily. So here we go. We've got our 4 triangles. So 360 divided by 4 gives you 90. And then, of course, again, your apothem splits in half. Also, if you guys have any questions at any point, please feel free to ask. Slow me down. Okay, I'll answer any questions you guys got. Alright, so then 45 degrees. And then again, we were told that the radius is 7. So that's this length here. Now, the 7 is the hypotenuse of our 45, 45, 90. So what we're going to need to do is use that rule, that the hypotenuse equals leg times rad 2. Because this is going to give us the apothem and the bottom side. They're both the same length. So we're going to have 7 equals a times rad 2. We're going to divide out the radical. And then we're going to clean it up because we don't want that radical down below. So 7 over rad 2. I'm going to multiply that by rad 2 over rad 2. So these multiply with these, the radicals cancel out, you're left with just the 2. So 7 rad 2 over 2. So this is your apothem. That's also going to serve to help us with part of the bottom side here. So if I take this, take 7 rad 2 over 2, and I double it, that's going to get rid of the 2 that's down below. So the side length is simply 7 rad 2. Alright, now our perimeter. There are 4 sides. Each side length is 7 rad 2. So we're going to have 28 rad 2. Got my perimeter, got the apothem. Let's get to it. So we're going to have our area equals 1/2 the apothem times the perimeter. So 1/2 of 7 rad 2 over 2 times, what part are you confused on there? You got to be a little more specific. I'll keep writing until you type it up. Oh, okay. So let's just show that math. So hopefully you recognize that this 7 rad 2 over 2 is this length here, which is that length there. So if I take that actual expression, right, because these are the same with doubling, so 2 times 7 rad 2 over 2, you could say, oh, 2 times 7 is 14, but then you're dividing it back out by 2, so that gives you 7 rad 2. You can also say, oh look, because I'm doing a whole number times a fraction, you can reduce, right? You can not cross cancel. I guess it's called cross canceling. I don't like that phrase. But either way, you're going to end up with 7 rad 2. And if you're still confused after that, just come in and bug me tomorrow. I know you guys have your test on Tuesday, so we've got plenty of time. But usually my even days are my least busy days, so it's usually a good day to ask me questions. Alright, so then I'm going to go back to this. And what we're going to do now is I'm going to do, you know, a little bit of math here. I don't really want to do too much calculation, so what I'm going to do is I'm going to take this 28 and reduce it with this 2. That's going to give me a 14 and a 1 down there. But then I notice, wait, 14 I can reduce with the 2. So then that 14 becomes now a 7. Alright, so I got 7 rad 2 times 7 rad 2. So that's going to give me 49 times the square root of 4, which is now 2. So 49 times 2, 98, and then of course centimeters squared. Now, like I told you all before, there are 2 other ways you could get to this area without using the 1/2 apothegms times perimeter. So if you remember what I taught you in class, you're more than welcome to use it. Otherwise, I'll be looking forward to seeing this math on that problem. Alright, find the area of the triangle. Now before I start writing the formulas, I need to look and see what kind of a triangle do I have. So right away, I'm given a side, an angle, and a side. Side, angle, side. We have that really awesome formula for that. That's our 1/2 BC sine of A, where B and C stand for the side lengths. And then our A represents our angle. So it's just simply substituting in our numbers. Again, I'm not using my calculator, so I'm going to leave this to you. Make sure your calculator is not in radians, that it's in degrees, otherwise you will not get the correct answer. Okay. 15, find the area of the shaded region. There are a couple ways of looking at this. You could say, hey, I want to find the area of each individual square and then add them up. You're more than welcome to do that. Right? You could say, oh, this length of 4 and this length of 5. 4 times 5 is 20. And that's going to be the same for these other rectangles. Don't confuse them for squares. Okay, they're definitely not squares. But that center one is definitely not going to be 4 times 5, because our length of 4 going across this way and our length of 4 going across this way will actually make that center area 16. So now you're going to say 20 plus 20 plus 20 plus 20 plus 16 to get your area. So that's 20, 40, 60, 80 plus 16, which is 96. Now, that's one way to do it. You can add up the little pieces. The other way is if you say, wait a second, Mr. T, I know I'm dealing with the total shape. So my total shape here is essentially a giant square. If I look at the total side length here and the total side length here, I meant to do this. Okay, so I could say that I have 5 plus 5 plus 4. I have a 14 by 14. Now the total area has these little gaps that are missing. I'm missing this space here, this space here. So a different way of doing this is I could do the area of my total, the total rectangle. Let's actually write that, total, minus the 4 rectangles, 4 area of our, oh my gosh, I cannot write today. There we go. Okay, so then my total area would just be 14 times 14. Happy Sunday. Yay. Now, the area of one of those squares, and thank goodness each square is the same length, right? So 5 times 5, that's a 25. Let's do a different color. 25, 25. So what I could do is I could say my total area of 14 squared minus 4 times 25. So 196 minus 100. And you're going to notice we get the same answer. As you should. We didn't change the area, we just looked at it from a different perspective. Okay. 16. It looks like I appear to have started it. So again, this is a very similar format as before. We're taking the total area. So our area of our total figure, which is a triangle, minus the area of the rectangle. I'm going to move that off to the side a bit. So the area of our triangle is going to equal 1/2 base times height. Well, our base, as you guys have seen some part of my marking, we're going to take this 2 plus the 7 plus the 4 to give us our base of 13 times the height, which is 10. Let's do a different color. So then I'm going to have 13 times 10, which is 130, divided by 2, 612, right, 65. The area of our triangle is 65. Now I'm not writing any units yet because, you know, those are going to be at the end. Let's see here. Now we're going to find the area of that little rectangle, which is right inside here, which is going to be a dimension of 7 by 6. So the area of our rectangle is just 7 times 6. Now the fun part, just take the difference between those two. So that's 65 minus 42, 23. And then I believe it's inches, nope, centimeters. All right. Nope, wrong button. As you guys can see, I'm getting a little tired. Honestly, I think I'm only gonna barely have enough energy for just this. I'm really exhausted, and I honestly think I might actually be getting sick, so I'm gonna want to get enough sleep tonight. I know it's 8:23, but you know, Mr. T's got to take care of himself. Okay, so this appears to be a composite shape. Composite just means it's made up of multiple shapes. So we have a trapezoid. Why? Here we go. And I probably shouldn't care if it's straight or not. There we go. Of course, Ariana. So we've got our trapezoid, which again, our base of 18 can go right there. It appears that, oh, okay. Well, we also know the height of this part here, which means if this is 8, that means this height is also 8. So let's just find that trapezoid. So the area of the trapezoid, that was not, let's just do area of trap. 1/2 base 1 plus base 2 times the height, and just go straight for that. So 1/2 of 30 times 8. So that should be 120. Now we have our bottom figure, which is our rectangle. Let me look on the computer real quick. Hopefully it'll turn up nicer, because otherwise I'll change that. Yeah, that's fine. You guys can see that. Right, so now the area of our rectangle, that's just going to be base times height, so 18 times 8. I don't have any way around this. 144. 9 times 8 is 72. And 18, you double that, so 144. So our total area is going to equal 120 plus 144. Okay. Now, another composite figure. So what we're going to do is we're going to go ahead and separate this into our two figures. Well, that's one way to do it. We could also, well, let's show both ways. Let's show both ways. In this figure, I have two trapezoids. So for the top trapezoid, we're going to have, well, let's call this area 1, and we'll call this area 2. So for area 1, it's going to be 1/2 of 7 plus 3 times the height of 2. So 1/2 of 10 times 2. So that should give us a 10. Area 2 is going to be 1/2 of, again, 7 plus 3, but I'm doing the opposite order now, 3 plus 7. Wow, that is definitely not a 7. But now our height is 3 for that one. So now I'm going to have 1/2 of 10 times 3, so that should give me 15. So my total area equals 10 plus 15, which is 25 meters squared. Now, alternatively, what you could have done was said, hey, overall, I have this rectangle of a sort. And inside of that rectangle, there was a triangular slice that was taken out. So we could say the area of the rectangle minus the area of the triangle. So again, our rectangle is just going to be 7 times 5. And then our triangle, you'll notice that the height of your triangle goes this way. So if our total length was 7 and part of the length is 3, that means the remaining part is 4. So 1/2 of your base, which again your base is right here, and the height is 4. So 1/2, 5 times 4. So that should get you your, let's see here, 5 times 4 is 20, 20 divided by 2 is 10. So we're going to have 35 minus 10, which is 25. So again, just a different way of doing it, but you guys will notice again, you should be getting the same answers. Alright, the last ones are our coordinate ones, and then I will be good, because I need sleep. So I'm going to plot this and figure out what shape I have. It does have 4 ordered pairs, so at least I know it should be a 4-sided figure. So here's F. And so now we have that shape. It appears that we have a parallelogram. So the area of a parallelogram, again, remember, is base times height. So here's my base length, 1, 2, 3, 4, 5, 6. Then our height, remember, goes perpendicular to that. So just count the distance between those two. 1, 2, 3, 4, 5, 6, 7. So then our area is just going to be 7 times 6. Which is 42. Now, since there are no units on the actual graph, we would say units squared. All right. Last one. The area of our polygon here, I'm given 3 ordered pairs, so that means it's probably going to be a triangle. So a 2, 1, 7, 1, 6, 7, 1, and then 6, 5. Boom. All right. So then again, area equals, for a triangle, 1/2 base times height. There's my base. My height is going to be the distance going vertically straight up. So 1, 2, 3, 4, 5. And then for our height, 1, 2, 3, 4. So the area equals 1/2, 5 times 4. And then that's 10. All right. Again, like I said, you guys have a little more extra time. You'll have your test on Tuesday. So just ask me questions tomorrow. I won't have a lot of free time in the afternoon, but just if you have any questions, email me. Hopefully this was helpful for you guys. If you watch this later, just ask me questions. Ariana, thank you so much for sticking through the live stream. Don't know who else is on, but hopefully this was helpful. And we shall definitely talk some more later. All right? Talk to you all later. Have a good night. Stay awesome and stay healthy. Bye.